We will now learn about a third type of conic section known as the parabola. We will learn its definition, its shape, and then its equation, and how to go about graphing it, some of the terminologies and features of a parabola, and then we will work through some examples as well. These are some of the topics that will be covered in this lecture. We'll graph parabolas with vertices at the origin, write equations of parabolas in standard form, graph parabolas with vertices not at the origin, solve applied problems involving parabolas, and identify conics without completing the square. Let's begin by defining a parabola. A parabola is the set of all points in a plane that are equidistant from a fixed line known as the directrix and a fixed point, the focus, that is not on the line. In this figure here, we see a parabola which is facing sideways, and this vertical dashed line is called the directrix, and outside the parabola the horizontal dashed line is a focus. This focus is not on the parabola, neither is it on the directrix. The property is that all points on the parabola are equidistant from a fixed line, which is the directrix, as well as from the focus, which is a point. The directrix is a line, the focus is a point along the horizontal axis. All right. We will now look at the standard form of the equation of a parabola. Now there are two different equations depending on whether the graph is facing sideways or it's turned up. In either case, the vertex is located at the origin, and if it's a sideways graph, then it's y squared equals 4 times px. If it is an upward turning graph parabola, then the equation is x squared equals 4p times y. However, what is p? P is the x-coordinate of the focus point for the first graph. All right, if the graph is turned sideways, then P represents the x-coordinate of the focus point. The focus point in that case is along the x-axis. If it's an upturned U or an upturned parabola, then the focus point has coordinates 0, p. The focus point is located on the vertical y-axis. It has coordinates 0, p, and the y-coordinate of the focus point is the value of p in the equation, 4 times p times y. In both cases, we see these dashed lines represent the directrix. The equation of the directrix is x equals negative p when the directrix runs vertically and the graph is faced sideways. If it is an upturned parabola, then the directrix is a horizontal line with the equation y equals negative p. We will now work on an example to find the focus and directrix of a parabola given its equation. The question says, find the focus and directrix of the parabola given by y squared equals 8x. Then graph the parabola. Now, whenever the equation is of the form y squared equals something, then generally it is a side opening parabola opening to the right. Now, the general form of this equation would be y squared equals 4px, and p will be one of the coordinates of the focus of the parabola. So let's pull up the solutions here. It says the given equation y squared equals 8x is in the standard form of y squared equals 4px. Therefore, we can equate 4p with 8 and write it as 4p equals 8 and then solve for p, and we will get the coordinates of the focus of the parabola. Therefore, 4p is equal to 8, therefore p equals 2. Therefore, we can say because p is positive, the parabola with its x-axis symmetry opens to the right. The focus is 2 units to the right of the vertex of 0, 0. The end point of the vertex of the parabola is positioned at 0, 0 in the standard form. The focus will be located at 2, 0. And the directrix of this parabola, since it opens to the right, will be a vertical line to the left of the parabola. All right. Now that we found the coordinates of the focus 2, 0, the directrix will be the line x equals negative p. It's a vertical line. It's just a negative of the value of p, which will be negative 2. That's the line of the directrix of this parabola. We now have to graph the parabola. In order to do that, we will use 2 points on the graph that are directly above and below the focus point. Now, because the focus is at 2, 0, all we do is substitute 2, the value of p for x in the parabola's equation, y squared equals 8x, and solve for y. So y squared equals 8 times 2. Substitute 2 into x. We will get y squared equals 16. Therefore, y will be equal to plus minus square root over 16, giving us y equals plus minus 4. Therefore, the points on the parabola above and below the focus point would be 2, 4 and 2, negative 4. So now we have a few points to graph the parabola. One would be the vertex at 0, 0. Then we have a point at 2, 4. Then we have a point 2, 4, and the other point is 2, negative. Here's the final step where we complete the graph. The focus is 2, 0. It's right here. And then the directrix will be at x equals negative 2. Correct? This would be the line. Let's draw a vertical line passing through x equals negative 2. This is the directrix. This point here is the focus, and this is the vertex of the parabola at 0, 0. And then we found 2 other points. One of them was at 2, 4 right here, and the other one was at 2, negative 4, 2, negative 4, and the other one was at 2, 4 right here. And we connect these points and get our right opening parabola. All right. Now there's another feature and terminology related to parabolas that we must know of. The term is a Latin phrase known as latus rectum, and related to parabola, it is a line segment that passes through its focus point, is parallel to its directrix, and has its end point on the parabola. In other words, it is this line passing through the focus point straight up and down and connecting the two ends of the parabola. If it's a side-faced parabola, then the latus rectum is vertical. If it is a parabola that faces up, then the latus rectum is a horizontal line passing through the focus point and connecting the two ends of the parabola along that line. All right. So again, the latus rectum of a parabola is a line segment that passes through its focus, is parallel to its directrix, and has its endpoints on the parabola. The length of the latus rectum for the graphs of y squared equals 4px, which is the graph on the left-hand side faced. A right open parabola has the equation y squared equals 4px, and the one that is opens up has the equation x squared equals 4py. For either of them, the length of the latus rectum is the absolute value of 4p. All right? Let's work on an example of finding the equation of a parabola from its focus and directrix. The question says, Find the standard form of the equation of a parabola with focus 8, 0. Those are the coordinates of the focus point, and directrix x equals -8. Now this equation of the directrix x equals -8 tells us that the directrix is a vertical line, and when the directrix is vertical, that means the parabola will be a right opening parabola. All right. Therefore, let's pull up the solutions. The focus 8, 0 is on the x-axis. We use the standard form of the equation in which there is x-axis symmetry, and the form of the equation is y squared equals 4px. When it's a right opening parabola, then the equation of that starts with y squared equals 4px. All right. Now, the focus is 8 units to the right of the vertex 0, 0. That's the focus point. 8, 0 means it is on the x-axis 8 units away from the origin, from wherever the vertex is. Now, P is positive and P equals 8. We have determined that. How do we know? Because P is the x-coordinate of the focus point. So even though they haven't specifically given us the value of P, we know that the coordinates of the focus point is 8, 0, and 8 will be the value of P. So the focus is 8 units away from the vertex, but P is positive and P equals 8. Therefore, y squared equals 4px. So y squared equals 4 times 8x equals 4 times 8 is 32. So that's how we come up with 32x. The final form of the equation of the parabola is y squared equals 32x. All right. Here's the graph of the parabola y squared equals 32x. The directrix is running vertically down, cutting the x-axis at -8. X equals -8 is the equation of the directrix. The vertex is located at the point of origin. Focus point is at 8, 0 right here. Right, and this is the shape of the parabola opening to the right.